My name is Hector. Hope you're all having a good day. I'm going to go over question 29. While driving to work last year, I was holding my coffee mug in my left hand while changing the CD with my right hand. Then the cell phone rang, so I placed the mug on the flat part of my dashboard. Then, believe it or not, a deer ran out of the woods and onto the road right in front of me. Fortunately, my reaction time was 0, and I was able to stop from a speed of 20 meters a second in a mere 50 meters, just barely avoiding the deer. Later tests revealed that the static and kinetic coefficients of friction of the coffee mug on the dashboard are 0.5 and 0.3 respectively. The coffee and mug had a mass of 0.5 kilograms, and the mass of the deer was 120 kilograms. Did my coffee mug slide? So, really right off the bat, some key things that you need to know that are important to realize is that we don't care what the static coefficient is, and we don't care how much the deer weighs. It never hits the deer is not involved, and if it slides, we won't ever have to calculate how far it slides. We just want to know, basically, does our force exceed, the force of the brake on the coffee mug, does that exceed our friction max? And that's really going to be how we're going to do this. We're going to use a lot of Newton's second law to just set this up and kind of go through it. So just to visualize it a bit better, we have a graph right here of just kind of the what I'll call the total system. The car, the road, the deer. The car's going at 20 meters a second towards the deer, which is 50 meters away. It will eventually slow down and not hit the deer. So if we go to a force diagram of our coffee mug, we can see that there's this. So when I first did this, I was a little confused, but we have basically, as the car slows down, because of Newton's third law, everything inside of the car is going to try to keep moving forward. Okay, right off the gate. So that means that what opposes that force, what keeps you from flying off your seat, flying off the car, well, that's friction. So in the opposite direction of motion, assuming this way is the way the car is moving, the coffee mug is going to want to continue going in that direction. So that Fs max is pointed that direction. Also, we have our normal force, we have our gravitational force, and the force of the brake is the other force that is acting on this. It's going to accelerate relative to the car because it's a flat surface, and there's a mass, so it's going to be a force. So going through this and setting it up, basically we need A, right? We need to know how quickly does this car decelerate, because it matters for how much force the coffee cup will be experiencing. So using a kinematic, using the V final squared kinematic specifically, because it doesn't require us to have a time, we can plug in known values. So our initial velocity, final velocity, which will be 0 because the car will come to a stop, and our delta S, which is the change, so 0 to 50. And we can solve it out for A. Doing that, we get negative 4 meters a second squared. Now that we have that, we can figure out what the force on the mug is. So F equals ma. I don't actually have it written out here, so let me just write it out really quick. So F equals ma, Newton's second law. And so we just have our mass and our acceleration, and that's giving us the amount of newtons the coffee mug is experiencing. It's experiencing a negative 2 newtons of force. So how much force will make it slide? What is the required what's the required force to basically beat out Fs max? So let's first figure out what the maximum friction force you can have is. So kind of going down, we know that the friction force maximum is equal to mu sub s times n. So mu is given to us in the question, 0.5, the static one specifically, not the kinetic one because it's not sliding. And then normal force is just mass times gravity. So doing that out, we get that 2.4 newtons is our Fs max. So obviously 2.4 is greater than 2. The coffee mug won't slide. Or you can kind of think of it as Fs max is greater than the force of the braking on the coffee mug specifically. So again, the coffee mug won't slide. So if we look back over here, it's basically saying that this force, so I don't actually have it drawn to scale clearly, but this line, so here, actually, let me just fix this line right now. Oh boy, this line, my poor coffee mug got much sadder, should be smaller than this Fs max line because it's winning, basically, and making the coffee mug decelerate with the car. it would definitely be an interesting question to see, would the liquid leave the cup? But that's definitely out of the scope of what we're learning right now. So that really just does it for the question. I hope you all have a good day. Hope this made sense. And yeah, have a good one.